All right. So the homework for today is right here. It's assignment 8. We're going to do graphing and solving quadratic inequalities. All right, so you're going to want to write these notes down. It's just the steps for graphing and quadratic inequalities in two variables. So if you know these steps, it's really not that difficult. The first thing you want to do is just graph it as if it was a normal equation. So you're probably going to find the x-coordinate of the vertex doing negative b over 2a and that kind of jazz. The important thing here is that if it's greater than or equal to or less than or equal to, you're going to use a solid line. And if it's greater than or less than, you're going to use a dotted line. Okay? Once you have a graph to determine which area you're going to shade, so ultimately what you're going to get is something, some parabola, and you're either going to shade the inside or the outside. You just pick any point on the inside and test it in the formula and see if it works. So if it's true, you graph on the inside. If it's false, you graph on the outside. And that's what step 3 says. So, all right, so again, the first thing we want to do is just graph it. Okay, notice this is just greater than. It's not greater than or equal to, so it's going to have a dotted line. But again, we're just going to do b over negative 2a to find the x-coordinate of our vertex. So that's going to be negative 4 over negative 2 times 1, which is 2. So the x-coordinate of my vertex is 2. To find the y-coordinate, remember you just plug it back in to this equation. So you would get y equals 2 squared minus 4 times 2 minus 5. So that's 4 minus 8 is negative 4 minus 5 is negative 9. So that's going to be your vertex at 2, negative 9. So you go over 2, down 1, 2, 3, 4, 9. Okay, and this is where you're going to kind of have to remember from last unit, or not last unit, the last quiz, how to graph. We're basically going from the graph of y equals x squared, which goes over 1, up 1, over 2, up 4. And we adjust it based on our a value. Here, the a value is 1. So you're just going to go from here, over 1, up 1, over 2, up 1, 2, 3, 4. And the same on the other side. And then when we graph this, remember it's going to be a dotted line because it is just greater than, not greater than, or equal. To determine whether you're going to shade on the inside or outside, you pick an x and a y value on the inside of the parabola. You can pick any value, but I always like to pick 0, 0 because that's really easy to plug in. So all I'm going to do is plug it into this equation. So 0 is greater than 0 squared minus 4 times 0 minus 5. And we just want to determine if that statement is true or not. So we get 0 is greater than negative 5. Is that true? Yeah, because it's on the inside, and that's an easy one to plug in. So it's going to shade, not always. So now I just shade on the inside. Next, we're going to graph two quadratic inequalities on the same graph, and then the portion where the shaded area overlaps is going to be your final solution. So this is a little involved, but not really any more difficult. This is the same equation we just did. So I can graph that 2, negative 9. Exactly. So I'm going over 1, up 1. Over 2, up 1, 2, 3, 4. So this is just the same graph we just did. Yes, because it's not equal to. And remember, I shaded in on the inside of that. So I'm going to do that in yellow. Okay, so I shade on the inside there. And now I need to graph my other equation. So you're going to do the same thing. You do b over negative 2a. And this one doesn't come out quite as cleanly, unfortunately. So you get negative 1 over negative 2 times negative 1. So you get negative 1/2 for the x-coordinate of your vertex. And then you plug that back into your equation. And I believe you get like 11.5 back. You guys could do that if you wanted to. For the sake of this example, it doesn't really matter. So you plug in, now you graph that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll just put it right here. Like I said, for the sake of this example, it doesn't really matter. All right, so now again, now my a value is negative 1. So I'm going to go over 1, down 1, over 2, down 4. So over 1, down 1, over 2, down 1, 2, 3, 4. Over 1, down 1, over 2, down 1, 2, 3, 4. From the vertex, right? Always from the vertex. So I get a graph that looks like that. So now I have to determine if I want to shade on the inside or the outside. So let's look. What's the value that's on the inside of my parabola? 0, 0 again, right? So I say 0 is less than or equal to negative 0 squared minus 0 plus 12. 0 is less than or equal to 12. Is that true? Yeah, it's true. So now I'm going to shade everywhere on the inside of this parabola. Okay? So I have all this orange. And then the part where the orange and the yellow overlap is going to be what we shade in. All right, so I'm going to go ahead now and shade in the part where it overlaps in blue. And then that's ultimately your answer. So just all here. No, when you're graphing it, that's all you have to do. So that would be your final answer, the area that's shaded in blue. And remember, this is a dotted line here, solid line, and then you're done. So the last thing we're going to do is solving these quadratic inequalities algebraically. So the first thing we want to do is solve for our zeros. So I'm going to put this in standard form. So I have x squared minus 3x minus 4 is greater than or equal to 0. And then I'm just going to factor it as if it was equal to. So here, this is factorable, right? So we don't have to do the quadratic formula or anything. We have ACB, negative 4, and negative 3. So what are two values that multiply to negative 4 and add up to negative 3? Negative 4 and 1, yeah. All right, so I have x minus 4 and x plus 1. So my two zeros are going to be x equals 4 and negative 1. Okay, so all I was doing there is solving for my zeros of the equation. All right, now I'm going to plot those two zeros on this number line over here. So I have negative 1 and I have 4. All right, and what I want to do is plug in different test points that are going to allow me to see whether or not this equation is true at that point. So here I have a 0, so I can put a closed circle. Here I have a 0 closed circle because it's equal to, greater than or equal to. And then what I'm going to want to do is pick different test points at different sections to see if it's true. So I could pick negative 2, 0, and 5. And what I'm going to do is plug each of those test points into this equation or this equation. It doesn't really matter which one. I'm going to do the top one just because that's what I did last class. So you have x squared. So you're testing at x equals negative 2. So we're trying to see if that is true. So we test x equals negative 2. You get negative 2 squared. Minus 4 is greater than or equal to 3 times negative 2. So you get 4 minus 4 is 0. 0 is greater than or equal to negative 6. Is that true? Yeah, it is. So that means I can shade in over here. So that means all values to the left of -1 are going to be solutions. Once you have that, chances are this is not going to work and this is going to work. But just to verify, we can go ahead and test the other points. So we can test when x equals 0. And you'd get 0 squared minus 4 is greater than or equal to 3 times 0. Negative 4 is greater than or equal to 0. Is that true? No, it's not true. So that means I'm not going to shade in that area. And then the last thing I'm going to do is test this point here at 5. Alright, so you plug it in. 5 squared minus 4 is greater than or equal to 3 times 5. And you get 21 is greater than or equal to 15. Is that true? Absolutely. So I can shade in over here. Alright, so the last thing I need to do is just write down the intervals that I shaded in. So you're going to write down in two different inequalities. So I would just say x is less than or equal to -1 and x is greater than or equal to 4. And you're done.